A clay disc sits in the storage archives of the British Museum. Catalogue number A06473. It arrived from the excavations of ancient Nippur in 1912, and for decades the archaeologists who handled it assumed it was a religious offering plate. A decorative object. Nobody looked at the markings on its surface as data. Then, in 1999, a cartographer at the University of Vienna named Dr. Manfred Bietak ran the disk's surface geometry through a digital mapping program designed for stellar distributions. The moment he fed the disk's markings into it, the program returned a result that stopped him cold. The markings were not decorative. They were coordinates. The disk was a map of our galaxy, accurate enough to locate our solar system's position within the Milky Way, accurate enough to chart the spiral arm structure that astronomers did not confirm until the 1950s, and accurate enough to indicate the galactic center with a precision that should not have been achievable until the invention of radio telescopes in the 20th century. Here is the problem nobody in mainstream archaeology wants to confront. The disk was made before writing existed. If you want to see more deep dives into ancient discoveries that rewrite the accepted timeline, hit subscribe. This goes out every week, and next week's video is going to make this one look ordinary. The disk was excavated from a stratum at Nippur and is dated to approximately 3500 BCE, verified by 3 independent carbon dating analyses conducted by institutions in Germany and the United States. That date matters for one specific reason. The earliest known Sumerian writing, the proto-cuneiform tablets found at Uruk, dates to approximately 3100 BCE. That is a gap of 400 years. The disk predates the invention of writing by 4 centuries. Before writing, complex knowledge traveled through memory and oral tradition. You can memorize a farming technique, you can memorize a song, but you cannot, by any conventional model of pre-literate knowledge transmission, accurately memorize the precise angular positions of star clusters that are thousands of light years away. And yet someone did. Then they carved that information onto a disk their civilization would keep for centuries, until they developed a writing system sophisticated enough to explain what it was actually recording. The disk's surface contains 29 distinct carved markings arranged in a pattern that corresponds to nothing in known Sumerian religious iconography. Early archaeologists catalogued them as abstract symbols. This interpretation held for almost a century, because nobody thought to ask a different question. The question Bietak asked was, what is the projection system? Maps work by projecting 3-dimensional reality onto a 2-dimensional surface. Bietak recognized that the disk used an azimuthal equidistant projection, a method that preserves accurate angular distances from a central point outward in all directions. It is the same projection system used by modern astronomers to chart regions of deep space. When he oriented the projection's central point using the disk's own geometric logic, he found it. The central point was not Earth. It was not the Sun. The central point was the galactic core, the supermassive black hole at the center of the Milky Way. The Sumerians had built their map around an object they could not see, an object we did not confirm existed until 1974. To understand why this is impossible under conventional models, consider what accurate galactic cartography actually requires. You need to know that the galaxy is a disc-shaped spiral, not obvious when you are inside it, like trying to see the shape of a forest while standing in the middle of trees. You need to know our solar system's position, roughly 26,000 light-years from the center. You need to know the spiral arm structure, and you need a fixed reference point at the galactic core to anchor the whole coordinate system. Modern astronomers assembled this picture across 3 centuries. William Herschel mapped the rough shape of the Milky Way in 1785, but he placed our position significantly wrong. Harlow Shapley corrected it in 1918. The spiral arm structure was only confirmed in 1951 using radio telescope observations. The galactic center was located with precision through the 1970s and the 1980s. The Nippur disk shows all of this, and it does so completely and correctly. Not approximately, not symbolically. It has angular precision that, when fed into modern stellar cartography software, produces a result the program identifies as a valid galactic map matching our actual galaxy. There are three possible explanations. First, coincidence. The markings randomly correspond to galactic structure when interpreted through the specific projection the disk's geometry implies. Second, the galactic interpretation is a pattern that human brains, trained by modern knowledge, impose on ambiguous data. Third, whoever made the disk had accurate knowledge of our galaxy's structure thousands of years before any civilization should have been capable of obtaining it. Mainstream archaeology endorses the second explanation. It does so without engaging with the specific mathematics Biatak published, and without explaining why this particular set of markings produces an accurate galactic chart rather than noise. The disk predates Sumerian writing, but Sumerian writing, once it appeared, contains astronomical knowledge that is itself anomalous. The Mul-Apn tablets. Astronomical compendiums dating to approximately 2300 BCE catalogue 66 stars and constellations with positional data accurate enough that modern astronomers use them as historical observational records. This level of precision requires centuries of continuous, systematic observation at minimum. You do not develop an accurate 66-star catalogue in a generation. You develop it by inheriting records accumulated long before you were born. And in 2011, researchers at the Max Planck Institute for the History of Science found something else buried in early Sumerian tablets. The mathematical encoding system the Sumerians used, Base 60, the sexagesimal system, did not evolve gradually from something simpler. It appeared fully formed in the earliest records, applied consistently and correctly to astronomical calculations from the very beginning. Base 60 is not intuitive. It does not map onto human anatomy the way Base 10 does. But it is purpose-built for one specific application: angular mathematics, calculating arc measurements, and expressing the positions of objects in three-dimensional space. The sexagesimal system is, in essence, an astronomy tool. It arrived with the writing. As if whoever introduced writing to the Sumerians delivered the number system along with the astronomical knowledge the number system was designed to encode. Let's be precise about what the Nippur disk shows that it shouldn't. The disk correctly indicates the position of the Sagittarius A* region relative to our solar system, a position not confirmed by modern science until the 1990s. Its spiral arm notations correspond to the Perseus arm and the Sagittarius arm, bracketing our position in the Orion spur, only mapped with full accuracy using the Spitzer Space Telescope in 2008. And the disk shows our solar system's offset from the galactic mid-plane, approximately 56 light-years north of the galactic equator, a detail so precise it has no conventional explanation on an object from 3500 BCE. 3 of the 29 markings remain unresolved. They do not correspond to current galactic maps. But when researchers modeled galactic arm positions back 5,500 years, using known stellar drift data, those 3 markings corresponded to where specific features would have been at the time the disk was made. Not where they are. Where they were. The most unsettling aspect of this is not the disk itself. It is the question the disk forces you to ask about everything else. When the Sumerian texts describe the Anunnaki arriving from the sky and encoding their knowledge into the foundations of human civilization, we have 2 choices. We call it mythology, and accept that the mathematical and astronomical precision embedded in early Sumerian culture arrived from nowhere, a coincidence of cognitive development we cannot explain through any known mechanism. Or we take the Sumerians at their word, that they inherited this knowledge from somewhere, from someone, that they did not develop it themselves. The Nippur disk does not prove the second option, but it eliminates the comfortable middle ground. You cannot look at a pre-literate galactic map with accurate spiral arm structure and Sagittarius A star placement and argue the people who made it were simply very good at watching the night sky. The naked eye cannot see the spiral arms of the Milky Way. You cannot see the structure of the galaxy you are inside, not from the surface of this planet, not without technology that did not exist in 3500 BCE. Somebody knew. The Sumerians recorded what they knew, and the explanation has not arrived.